Welcome back to another video. In this video, we're going to talk about factoring. Factoring what? Factoring difference of squares. So difference of squares, first of all, has to involve a difference. Difference means subtraction. And then the other thing is it has to have only two terms, okay? So whenever you have two terms and you're trying to factor, one of the things you want to check for is to see if that can be written as the difference of squares. So difference of squares look like this. X squared minus y squared. There's your difference and there are your squares. So if you have two things squared and you're taking the difference between those two things, then that can break down into x plus y, x minus y. And it doesn't matter which order you write these in. You can write the x minus y first and the x plus y second, or vice versa. But if you have the difference of two squares, it can factor down like this. So for example, if you had x squared minus 9, that's the same as saying x squared minus 3 squared. So since that's x squared minus 3 squared, that is the difference of squares. So you can write that as x minus 3, x plus 3. Okay, so for this first example, we have three different expressions we want to factor. And for this first one, it's p squared minus 16. So p squared is in fact something squared. That's p squared. And 16 is 4 squared. Since I can write 16 as 4 squared, then this is the difference of squares. So I will write this as p minus 4 times p plus 4. If I was to go multiply this back out, it would give me p squared minus 16. Okay, and if you don't believe me, you can go check and see. Alrighty, what about this one? X squared minus 8. X is x squared. X squared is just x squared. But what about 8? Can you rewrite 8 as something squared? So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So no, you cannot rewrite 8 as something squared, and so therefore this one cannot be factored, which we call prime. A prime polynomial means it cannot be factored, okay? What about this one? P squared plus 16. So this is p squared and this is 4 squared. However, this is not a difference. That is a plus sign. So since it's not a difference, then this one also cannot be factored, and this one also would be considered prime. So if you have two terms, you want to check to see if it can be written as the difference of two squares. But in order to be the difference of two squares, it has to be a subtraction. Okay, now we want to factor 25m squared minus 4. So it's two terms. It has a subtraction. So let's check to see if it's the difference of two squares. Meaning, can I rewrite 25m squared as a square? And can I rewrite 4 as a square? Yes, I could rewrite 25 as 5 squared and m squared as m squared. So that becomes 5m squared. Because I'll square both of those. That'll give me 25m squared. 4 is 2 squared. So since this is the difference of two squares, and this factors in the 5m minus 2, 5m plus 2. Again, it doesn't matter which one I write first. It doesn't matter which one I write first because multiplication is commutative, meaning you can switch it and you get the same thing. A times B is B times A. Okay, now one last example. We want to factor 81y squared minus 36. And if I look at this, I see it's two terms, and so what I want to do is check to see if it can be written as the difference of two squares. So this is 9y squared because 81 is 9 squared, and y squared is y squared, and this is 6 squared. So yes, this is the difference of two squares. So this factors into 9y minus 6, 9y plus 6. Now if you look at these, you should notice, hopefully you notice, that both of these have a 3 in common. So these have a GCF that I could pull out, and it's 3. So I could pull out 3. If I pull out 3, that leaves me with 3y minus 2. Same thing here. I could pull out a 3 here, and that leaves me with 3y plus 2. Well, 3 times 3 is 9, so this will factor into 9 times 3y minus 2 times 3y plus 2. And so that's how you would factor that. So now I actually did this by looking and noticing that those were the difference of two squares, but technically when you factor, the first thing you're supposed to do is pull out the GCF. So if I would have looked at here in the beginning to see if there was a GCF, there is a GCF there, and that GCF is 9. So now I'm just showing you another way you could have did it. So you could have pulled out a 9 from the beginning and you would have got 9y squared minus 4. And then this is the difference of two squares. That's 3y squared minus 2 squared. So that would have factored into 3y minus 2, 3y plus 2. So if you would have pulled out the GCF in the beginning, you still would have got the same result. You wouldn't have to go through and pull out the GCF out of both of them and then multiply. So either way it go, you still get the same answer. So go whichever way you like best. But technically you're supposed to look to see if there's a GCF in the beginning to pull out. Okay. So this is how you factor two terms. You want to check for difference of squares. This is one of the things you can do when factoring two terms. If you have any questions whatsoever, make sure you include them in the comments below. If this video helped you, let me get you to click that thumbs up, the like button. And if you haven't already, make sure you hit that subscribe button. Thank you for tuning in, and I will see you in the next video.